Hi there. In today's video, we're looking at question 6 from the November 2024 Maths Paper 2 exam. Okay, let's jump straight into it. So we've been given the cos x minus y compound identity, and in 6.1.1 we've been asked to use this compound angle identity to derive the formula for cos x plus y. Now, for us to go from that to that, it means that this y also needs to become negative, because a negative multiplied by a negative gives us a positive. So let us begin there. Cos x minus negative y will therefore be equal to cos x cos negative y plus sine x and sine negative y. Okay, now we're going to use reduction formulas. So cos x cos negative y is in the fourth quadrant, meaning it's also going to be positive. So this is just cos y. Sine x is sine x. Sine negative y is in the fourth quadrant, and sine is negative over there. So now we end up with just cos x cos y, and then this negative comes here, and that's how we end up with, okay, what's going on? This is a y. Yeah, so here we end up with sine x sine y, and there we have proved that compound angle identity. Okay, moving on to 6.1.2. Hence or otherwise, we need to show that the left-hand side is equal to the right-hand side. Okay, so let's start with the left-hand side, because that's where more work is. So left-hand side will be equal to cos 90 degrees minus x. I think we had a cos y plus sine negative y cos 180 degrees plus x. And in the denominator, we have got cos x cos 360 degrees plus y plus sine 360 degrees minus x sine y. Okay, let's simplify further. So starting over here with cos 90 degrees minus x, that's reduction formulae, or a step further is actually co-functions, also known as co-ratios. So then cos 90 is in the first quadrant, which gives us sine x. And then cos y is just cos y plus sine negative y. We know this is now in the fourth quadrant, so that becomes sine y, negative sine y. And then lastly, cos 180 plus x is in the third quadrant, and only tan is positive there, so this becomes a negative cos. Okay, now let's deal with the denominator. Starting with just cos x, and then 360 plus y. We've done one full revolution and gone back to the first quadrant, and cos x, well, now it's cos y, is also positive there. Put a bracket, and then sine 360 minus x. Sine is negative in the fourth quadrant, so it's negative sine x. And then sine y is just sine y. Okay, so now it's starting to take shape. Simplifying everything further, we've got sine x cos y, negative and a negative make a positive, so that's just sine y cos x Down here, cos x is still the same, cos y, and then this makes it negative. Now we've got sine x and sine y. Okay, it's now starting to take shape. So now we can recognize the compound angle identities that are present. This first one, let me make it light blue. This is the compound angle for sine x plus y identity. And the bottom one, we've already seen it in question 6.1.1. This is the one for cos x plus y. Now, what you should recognize is we've got sine over cos. And whenever we've got sine over cos and they are having the same angle, it means that we can reduce it to tan. And they both have x plus y, so our tan will also be x plus y. And you can now see we have proved the identity, and this is equal to the right hand side. Okay, this is an interesting question. Okay, let's now move on to 6.2, where we've been given that function and we've been asked to solve for x within this interval. And we are told that the function is equal to 2. So the approach we're going to take here is we're going to use the general solution approach, but then we'll actually be able to get the values of x since we have the intervals. So let us start. So we're looking at 6 sine squared. 6.1.3. So we've got the root of 6 sine squared x. Remember it was 11 cos 90 plus x plus 7. And we're told this whole thing is equal to 2. To get rid of our root sign, we're going to square both sides since it's a square root. So that then leaves us with just 6 sine squared x minus 11 cos. We'll sort out this 90 degrees plus x very soon. And then where did this 9 come from? It's a 7. Here it's a 7. I don't know where that 9 came from. Plus 7. And this is now equal to 4. Okay, now we can deal with this cos 90 degrees plus x. So 6 sine squared x minus 11. 90 degrees plus x is again co-ratios. Other people know them as co-functions, which means we're now converting to sine. But because it's 90 plus x, we're in the second quadrant. And in the second quadrant, cos is negative. So then our answer is going to be negative sine x. Even though sine is positive in the second quadrant, the original form is that of cos. So therefore, we still keep the negative. And then here, plus 7 is equal to 4. Alright, so now we've simplified everything. It's looking like a trinomial, so we can take the 4 to the left. So now we have sine squared x minus 11. This is now plus sine x plus 7 minus 4 is 3. And this is equal to 0. We've now reached a point where we can actually factorize this. So let's start with what's going to give us 3. It can only be 1 and 3. And it looks like here we have positive, and then something that will give us 6 and 11 in there. When we multiply out, looks like we might have 3 sine x, and here it will be 2 sine x. Let me just write it better to utilize the space we have. There we go. It's Spread that out too. Nice. So now we can solve for each bracket. Starting with 3 sine x plus 1 is equals to 0. We can take the 1 to the right. Divide both sides by 3. You end up with sine x being equal to negative 1 over 3. Let's look at the other bracket, 2 sine x, and this will be plus 3 is equal to 0. 2 sine x is equals to negative 3. Divide both sides by 2. We've got sine x being equal to negative 3 over 2. Now negative 3 over 2 is like approximately 1,5. We are dealing with a normal sine function, the standard sine function, and the maximum and minimums for a standard sine function is 1, positive 1, and negative 1 being our minimum. So that means we'll never get to negative 1.5. And automatically, without looking at your calculator, you can tell that there is no solution. But you can try and solve this in a calculator and get the angle, and you'll see that there really is no solution for x. Now, coming back to the one that did have a solution, here we need to get our reference angle, because remember I said we are taking the approach of general solution, but then we can get the specific angles since we have that interval from 0 to 360. So now our reference angle is going to be equal to 19,47 degrees, and we get this by taking shift sign and then putting in 1 over 3. So how I do it, I focus on, we want where sine is going to be negative, and sine is negative in the third quadrant and the fourth quadrant. So let's come up with equations for the third and the fourth quadrant. So in quadrant 3, we're going to have x being equal to, so in quadrant 3, the equation there is 180 degrees plus the reference angle, which is 19,47. That's how we're going to solve for it. And this will be equal to, adding this, 199,47 degrees. So that's our solution for the third quadrant. And then in the fourth quadrant, where sine is also negative, x is going to be equal to 360 degrees minus our reference angle, and that one is 19,47. And simplifying this, you get 340,53 degrees being our second solution. Okay, so we didn't have to write plus k dot 360 since we are looking at the specific interval between 0 and 360, limiting us to just the third and the fourth quadrant and allowing us to actually get the specific values. But if this was just general solution, you would have plus k dot 360, where k is an element of integers. Okay, that's it for 6.1.3. Oh, it was 6.2. Why am I calling it 6.1.3? Okay, now moving on to 6.3.1. Let's look at that function. So we've got g of x, okay, and we need to calculate the maximum value of g. Now, before we try and figure out how to calculate the maximum, we can actually simplify this equation because we can identify that it appears that there is the double angle for cos over here. So let us simplify that and see. 6.3.1. So g over x is equal to 4 minus 8 sine squared x, everything divided by 3. Okay, so the double angle equation is 1 minus 2 sine squared x. That means that for us to end up with this, we would have factored out 4. So that's how we end up looking like that. And here we've got a 3. So now that we can clearly see our cos of x double angle, we can actually just simplify this to 4 over 3 cos 2x. Now this is something we can work with to try and get the maximum value. Now, we need to realize that we are working with a cos function once again, and a cos function has a maximum of 1 and minimum of -1. And this value is therefore going to affect the amplitude. So if we can get the maximum of a normal cos function by itself, which is this, which we said would be 1, that means when we multiply it by the new amplitude, it will give us a new maximum. So therefore, 4 cos 2x maximum is equal to 1, right? So therefore, 4 over 3 multiplied by cos 2x, where this is just your amplitude, that means it will be equal to, the max will now be equal to just 4 over 3. And that is our final answer. So our understanding of trig functions is very essential for us to be able to solve this problem. Okay, let's move on to the last question, 6.3.2. We've been asked to write down the smallest possible value for which g will have a maximum value in the interval of x as an element of values between 0 and 360. But we have to be very, very careful. And that is because here we've got a curved bracket. That means we cannot include the 0, but the square bracket means we can include the 360. So let's see. 6.3.2. Okay, we are looking at the function 4 over 3 of cos 2x, and we said we know now that this is our maximum value. The standard cos graph looks something like this. Here's 0, 360, 180. And let's say this is 1, and somewhere here is -1. So your standard one is 90 and 270. Looks like this. Let me use a different color. That at 180 it hits its minimum. At 360 it's cut through. At 270 it cuts to 0. 360 it's back at 1. Something like this. It's just my sketch isn't the best. So this new graph that we have, the 4 over 3, we need to first realize that we've got that coefficient of x, which affects our period. So the period of our new function is going to be 360 degrees divided by 2, which is now 180 degrees. And we also said 4/3 affects the amplitude, which means that our function is now a little bit more stretched. 4/3 is like 1 1/3, which is like 1,3333. So our function is now sort of smaller and slightly taller. And trying to squeeze that in here, let me pick purple. Firstly, our period is now 180, so we have a full wave at 180. And everything is now, so that means the minimum is now here, and the maximums are now here and here. And it now looks something, oh, and our amplitude has changed, meaning I now need to extend this and 1,333 somewhere there. So it actually now looks something more like that. Ooh. Okay, it now looks something like that. That is what our function looks like. So we can now see that based on our interval from 0 to 360, where 0 is excluded, the other value that gives us a maximum is actually just at 180, because our maximums are over here at 0 and back at 180. That is what our function looks like. So if 0 is excluded, the only other smallest value that will give you a maximum is 180. So therefore, our final answer is x is equal to 180 degrees.